Hello again and welcome. I am so glad you have found your way back to this quiet corner of the cosmos. Perhaps your day was filled with noise and haste, or perhaps you are simply one of those souls who finds more comfort in the grand silent mysteries of the universe than in the familiar patterns of the world below. Either way, this journey is for you. There is nothing left to do but to let go. Allow your mind to soften, your breath to deepen, and your body to feel light, as if gravity itself has loosened its hold upon you. Because tonight, we are not visiting the familiar shining cities of stars. We are not tracing the well-known paths of constellations. Instead, we are drifting toward the fringes, to the strange and whispered about corners of the universe. We are seeking out the phenomena that defy our easy explanations, the cosmic apparitions that make even seasoned astronomers pause in quiet wonder. We will be exploring the most ethereal, the most bizarre, the most beautiful and unsettling structures that space has to offer. Some call them weird, but perhaps they are simply speaking a language our science has not yet learned to translate. They are not monsters in the dark. They are cosmic poetry, written in a syntax of gravity and light that we are only just beginning to decipher. So let yourself float. Let the concerns of the day dissolve into the vast dark tapestry that awaits. Tonight we journey into the heart of the uncanny, not with fear, but with a gentle and boundless curiosity. There is only stillness here, and the slow, patient unfolding of cosmic enigmas. Let us begin our drift toward the first of these great, silent wonders. We drift now toward a place of impossible scale and breathtaking form, a celestial landscape that seems more like a dream than a reality. Before us, rising out of a glowing sea of interstellar gas, stand colossal pillars of dust. They are not stone, but they possess a weight and a presence that feels ancient and monumental. They are the pillars of creation. They reach upward for light years, their forms sculpted by forces we can barely comprehend, their peaks and valleys shrouded in the thin, cold fog of molecular hydrogen. To look upon them is to feel as though you have stumbled into the workshop of a god, where the raw material of the universe is being molded into forms of profound and solemn beauty. One pillar is taller, stretching nearly 4 light years from its base to its ethereal tip. To travel its length at the speed of light would take longer than the entire recorded history of human civilization on Earth. Our whole solar system, from the Sun to the farthest reaches of Pluto's orbit, would be but a tiny, insignificant speck lost within the swirling dust of its majestic form. These are not solid structures you could stand upon. They are unimaginably vast, yet unimaginably diffuse clouds. If you could fly through them, you would find the space between each grain of dust to be wider than the space between the Earth and its moon. It is an illusion of solidity, a trick of distance and of light. The pillars appear as dark, brooding mountains set against the vibrant glowing backdrop of the Eagle Nebula, the star-forming region they call home. They are dark because they are cold, barely a few degrees above the absolute zero of empty space, and in their cold, dark hearts, something miraculous is taking place. They are not just sculptures, they are cradles, they are wombs. The dust that forms their towering shapes is the very same dust from which new worlds are made. It is a fine powder of carbon and silicate, the ashes of long-dead stars, now gathered together by the patient, invisible hands of gravity. And within their deepest, most hidden recesses, this dust is collapsing, slowly, inexorably, pulling itself into dense knots that will one day, millions of years from now, ignite with the fire of nuclear fusion and become new suns. The pillars are a promise, a silent testament to the universe's endless cycle of renewal. They stand as quiet, colossal monuments to the act of creation itself, forever shaping the future in their cold, dark, and beautiful embrace. But there is a profound and beautiful paradox at the heart of these majestic pillars. They are a place of birth, a serene nursery for infant stars, yet they are also a scene of constant, slow-motion destruction. The very light that allows us to see them is also the force that is unmaking them. The glowing nebula that surrounds the pillars is lit by a cluster of massive, hot, young stars that lie far above them. These stars are cosmic giants, burning with a ferocious intensity, and they unleash a torrent of ultraviolet radiation and powerful stellar winds, an invisible storm of particles that rushes through space. This storm is crashing against the pillars, relentlessly, moment by moment. The radiation heats the cold dust and gas, causing it to evaporate, to boil away into the void, like mist vanishing under a morning sun. The pillars are not static. They are in a state of constant, gentle erosion. Their surfaces are being peeled away, layer by silent layer. The image we see, captured by our telescopes, is not of a permanent monument, but of a fleeting, ephemeral structure, caught in a delicate and temporary balance between the inward pull of its own gravity and the outward blast of radiation from its stellar neighbors. The very stars that are being born within the pillars contribute to their demise. As a new star ignites in the dark, its own light and heat begin to push away the very dust and gas that formed it, clearing out its own small pocket of space. It is a cosmic chick, pecking its way out of its own shell, and in the process, the shell is destroyed. Creation and destruction are not two separate events here. They are a single, intertwined process, a slow and graceful dance that unfolds over millennia. The beauty of the pillars lies precisely in their impermanence. We are looking at a ghost, a snapshot of what these structures looked like more than 7,000 years ago, for that is how long their light has taken to travel across the vastness of space to reach us. It is possible, even likely, that the pillars we gaze upon with such awe have already been destroyed, their magnificent forms completely eroded and scattered by the stellar winds. We may be looking at a memory, a final, beautiful echo of a structure that no longer exists. They teach us that in the universe, the most profound acts of creation are often inseparable from their own undoing, and that the most breathtaking beauty is often the most fragile, a fleeting masterpiece sculpted from dust and light, destined to fade back into the silent darkness from which it came. We leave the towering forms of the pillars behind and drift now toward a different kind of cosmic apparition. This one is not a sculpture of shadow and dust, but a phantasm of pure light. As we approach, it resolves itself out of the darkness, a vast and luminous structure that is at once beautiful and deeply unsettling. It hangs in the void like a single colossal eye, staring back at us from across the immensity of space. It is the Helix Nebula, but many who have seen its image call it something else: the Eye of God. The name is born of an instinctive human reaction to its shape. At its center lies a tiny, brilliant point of light, a white dwarf star that glitters like a pupil. Around it, vast, concentric rings of iridescent gas form a cosmic iris, painted in hues of ethereal blue-green and deep glowing red. The entire structure is threaded with a delicate lacework of darker filaments, stretching outward from the center like cosmic eyelashes. It is so perfectly formed, so uncannily reminiscent of a living eye, that it feels less like a random cosmic accident and more like a deliberate conscious presence. The scale of this eye is beyond all human comprehension. It is more than 2.5 light years across. If you were to place our sun at its center, all the planets, including distant Neptune, would be contained within an infinitesimally small point within its pupil. It is a structure so vast that it dwarfs entire solar systems, yet it possesses a delicacy and an intricate detail that is breathtaking. The colors are not paint. They are the light of atoms, energized by the intense radiation from the central star. The deep reds are the glow of hydrogen and nitrogen, the fundamental building blocks of the universe. The brilliant blue-greens are the signature of oxygen atoms, heated to thousands of degrees. It is a chemical portrait of a dying star, a map of the elements it created during its long life, now displayed for the cosmos to see. To gaze upon it is to feel a sense of profound and tranquil awe. It does not feel like a menacing gaze, but a wise and ancient one. It is the quiet, patient stare of the universe itself, a silent reminder of a perspective that spans billions of years and encompasses galaxies. It seems to hold a quiet knowledge, a serene understanding of the cycles of existence that we can only glimpse. It is a window into the soul of the cosmos, vast, colorful, and utterly beautifully silent. This great celestial eye, for all its serene and godlike appearance, is not a monument to a deity. It is a funeral pyre. It is the beautiful, luminous ghost of a star that was once much like our own sun. For billions of years, that star lived a stable, quiet life, fusing hydrogen into helium in its core. But its fuel eventually ran low. In its final stages, it swelled into a vast, bloated red giant, its outer layers expanding far beyond its original size. Then, in a series of gentle, pulsating waves, the star began to shed these outer layers. It was not a violent supernova explosion, but a slow, graceful exhalation, a final luminous sigh that pushed its atmosphere out into the surrounding space. These expanding shells of gas are what we now see as the colorful iris of the great eye, and at the very center, the tiny, jewel-like point of light is the star's exposed core, a white dwarf. It is an object of incredible density, the mass of a star compressed into a sphere the size of the Earth. It is no longer producing new energy, but it is still incredibly hot, and its intense ultraviolet light shines outward, causing the gas shells it once shed to fluoresce, to glow with the brilliant colors we see. The Helix Nebula is a vision of our own solar system's distant future. In about 5 billion years, our sun will follow the same path. It too will swell and shed its layers, creating its own magnificent planetary nebula. For a brief cosmic moment, it will paint a similar masterpiece across the heavens. The atoms that currently make up our world, our bodies, the very air we breathe, were themselves forged in the hearts of stars that died in this way long ago. This great eye is not just a spectacle of death. It is a profound symbol of cosmic recycling. The elements it casts out into space, the rich mixture of carbon, oxygen, and nitrogen, will drift through the interstellar medium for millions of years. Eventually, they will mix with other clouds of gas and dust, and will be drawn together by gravity to form a new generation of stars and planets. It is a promise of renewal. The end of one star's life is the beginning of the raw material for countless others. The eye is a reminder that in the universe, nothing is ever truly lost. Matter is simply rearranged. Death is not an ending, but a transformation into a new and beautiful form, a quiet, radiant release that seeds the future with the potential for life. It is the universe's most elegant and beautiful way of beginning again. We turn our attention now from the ghosts of stars to the mysteries of entire galaxies. We drift toward an object that seems to defy the very logic of galactic formation, a structure so peculiar, so geometrically perfect, that it appears less like a natural creation and more like a deliberate cosmic artifact. It is known as Hoag's object. From a distance, it looks like a celestial jewel dropped onto the black velvet of space. There is a core, a small, dense, and almost perfectly spherical ball of ancient yellow stars. It glows with the soft golden light of suns that have been burning for billions of years. But surrounding this ancient core is a feature of impossible elegance, a perfect luminous ring of brilliant blue light, completely detached, separated from the core by a moat of profound and startling emptiness. This blue ring is a river of young, hot, massive stars, burning with the fierce, bright intensity of stellar youth. It is a place of active star formation, a vibrant, living circle of creation. The contrast is breathtaking. At the center lies an old, quiet, elliptical-like galaxy, a city of aging stars. Far beyond it, with almost nothing in between, lies a young, dynamic ring, a vibrant suburb of stellar newborns. The gap that separates them is the true heart of the mystery. It is a void spanning thousands of light years, a region so devoid of light and matter that it appears almost perfectly black. It is not just dark, it is empty. This structure challenges everything we think we know. Spiral galaxies have arms that connect to their centers. Elliptical galaxies are smooth, featureless spheres. But Hoag's object is neither. It is two separate, distinct populations of stars, one ancient and one young, existing in a state of perfect concentric alignment, yet held apart by an inexplicable chasm. It is a cosmic wedding ring, perhaps, with a golden band and a setting of blue diamonds, but the finger that should wear it is missing, leaving only an unnerving void. It is a lonely object, a galactic orphan that does not seem to belong to any known family of galaxies. It floats in the intergalactic darkness, a perfect silent question mark, asking a question about its own origin that the universe so far has refused to answer. The sheer strangeness of its form has led astronomers down a path of beautiful but ultimately unsatisfying speculation. The mystery of what it is matched only by the mystery of how it came to be. Perhaps, some thought, it is the result of a cosmic collision, a smaller galaxy punching a clean hole through the center of a larger one, triggering a ripple of star formation that expanded outward into a perfect ring. But if that were so, we should see the wreckage, the distorted shapes, the tidal streams of stars left behind by such a violent encounter. Yet, there is none. The core is too perfectly round, the ring too exquisitely uniform. There is no sign of a galactic struggle, only a strange and serene order. Another idea suggests that it was once a normal barred spiral galaxy, and the central bar of stars became unstable, eventually dissolving and shaping the gas into a surrounding ring. But the core shows no evidence of ever having had a bar. It is a smooth ancient sphere, seemingly undisturbed for eons. And so, the object keeps its silence. It offers no clues, no remnants of a chaotic past. It simply is. It exists as a quiet refutation of our neat and tidy categories. It may be that we are witnessing a phenomenon so rare that we have only found one example, a 1 in a billion cosmic accident, whose true cause we may never fully uncover. It is a humbling thought. It reminds us that the universe is under no obligation to make sense to us. It creates forms of beauty and strangeness that lie far outside our limited experience. Hoag's object does not need our explanation to be beautiful. Its existence is its own justification. It floats in the dark, a perfect circle of blue fire around a golden heart, a testament to the fact that not all questions are meant to be answered. Some are simply meant to be asked, to be wondered at, to be held in the mind as a symbol of the infinite, an often silent imagination of the cosmos. Our journey now takes us away from the things we can see, the grand structures of light and dust, and into the realm of the unseen, the world of whispers and echoes. We are no longer looking, but listening. We are tuning our senses to the faint, transient murmurs that ripple through the fabric of space-time. And in this realm, there is nothing stranger than the phenomenon known as a fast radio burst. Imagine you are standing in an infinitely large, infinitely quiet room, a chamber of perfect and absolute silence that stretches for billions of light years. And then, for less time than it takes you to blink, a single, impossibly loud shout echoes from the far wall. And then, there is only silence again. That is what a fast radio burst, or FRB, is like. It is a blast of radio waves, a form of light our eyes cannot see, that arrives from the distant universe. It is not a gentle hum or a steady glow. It is a spike, a sudden, overwhelming surge of energy that lasts for only a few milliseconds, a few thousandths of a second. It is a cosmic firefly, winking once in the eternal night and then vanishing as if it were never there. Yet, in that brief, fleeting moment, it can release more energy than our own sun produces in an entire day. It is a flash of lightning in a silent, starless sky, a momentary flare that can outshine entire galaxies in the radio spectrum. These bursts travel for unimaginable distances, for billions of years, crossing the vast, cold emptiness between galaxies to finally arrive at our radio telescopes on Earth. As they travel, they pass through the thin, ionized gas that fills intergalactic space, and this journey subtly changes the signal, stretching it out in a way that allows us to measure how far it has come. And the distances are staggering. They are not from our own galaxy. They are echoes from the deep, deep past, from a time when the universe was much younger than it is today. To detect one is to catch a single fleeting whisper from the other side of creation, a momentary message in a bottle that has been floating on the cosmic ocean for eons, telling us that the universe is not as quiet as it seems. It is punctuated by these moments of incredible, inexplicable power, these shouts in the dark that come and go before we can even begin to understand what they are. And from where does this impossible momentary shout originate? What cosmic engine could be powerful enough to generate such an astonishing amount of energy in the blink of an eye, and then fall completely silent? This is the profound mystery at the heart of the fast radio burst. For years, astronomers were baffled, proposing everything from colliding black holes to signals from extraterrestrial intelligence. The sheer variety of theories was a testament to how little we understood. But recently, a consensus has begun to form around one of the most extreme and bizarre objects in the known universe, the magnetar. A magnetar is the hypermagnetic husk of a dead star. It is a type of neutron star, an object already so dense that a single teaspoon of its material would weigh billions of tons. But a magnetar is a neutron star with a magnetic field of unimaginable reality-bending strength, 1,000 trillion times stronger than Earth's. This magnetic field is so powerful that it can buckle the star's crust, causing colossal starquakes that release a torrent of energy into space. It is thought that a single violent reconfiguration of this magnetic field could be the source of these cosmic bursts. But even this explanation is not complete. Some FRBs have been observed to repeat, flashing intermittently from the same point in the distant sky. This adds another layer of complexity. It is not a single cataclysmic event, but something that can happen again and again. It is a slumbering beast that awakens periodically to let out a ferocious roar. The signal is a message, but the language is pure energy, and the sender is the ghost of a star, wrapped in a magnetic field that defies comprehension. And yet, the mystery still lingers. The idea of a signal, a brief and structured pulse from the deep, will always invite our wildest dreams. It is a whisper that speaks directly to our deepest, most primal hope that we are not alone. While the magnetar theory is the most likely, the FRB remains a symbol of the profound and beautiful unknown. It is a reminder that the universe is still full of monsters, not of teeth and claws, but of physics so extreme they border on magic. It is a call for us to keep listening, to keep our instruments tuned to the great dark silence, waiting patiently for the next impossible shout from the other side of the night. We leave the realm of fleeting radio shouts and turn our senses towards something else, a phenomenon born not of a momentary outburst, but of an impossible, enduring rhythm. In the great, static-filled silence of the cosmos, between the random hiss of distant galaxies and the faint, ever-present echo of the Big Bang, there are points of astonishing regularity. They are the metronomes of deep space. We find them as we listen, sifting through the endless noise for a pattern, a signal that repeats with a precision so perfect it defies belief. This is the signal of a pulsar. It is a pulse, then a pause, a tick, then a talk, a single, sharp beat that arrives again and again and again, with a faithfulness that would shame the finest clock ever built by human hands. Some spin and pulse hundreds of times every second, a cosmic drumroll of unimaginable speed. Others are slower, a more deliberate, patient beat, like the slow turning of a celestial lighthouse beam, sweeping across the cosmos in a great, silent arc. This is not the warm, steady glow of a star. It is a strobe light in the cosmic cathedral, flashing with a rhythm that is its unique and unchangeable signature. The pulses are not light in the way we see it, but beams of radio waves, X-rays or gamma rays, a focused torrent of energy that for a brief moment blazes with an intensity that can be detected across thousands of light years. To find one is to find a point of perfect order in a universe that so often seems ruled by chaos. The regularity is so profound, so unwavering, that networks of these pulsars are being used as a galactic navigation system, a cosmic GPS that could one day guide spacecraft through the interstellar void. Their combined steady beats form a timing array so precise that it can detect the faint, subtle ripples in space-time itself, the gravitational waves that stretch and compress the universe as they pass. These pulsars are not just curiosities. They are tools. They are the universe's own master clocks, ticking away the cosmic seconds with a patience and precision born of the most extreme physics imaginable. To listen to a pulsar is to hear the heartbeat of a ghost, a steady, rhythmic pulse that speaks of order, of endurance, and of a strange, beautiful life after death. This cosmic clock, this lighthouse of impossible precision, is one of the most paradoxical objects in the universe. It is a monument to order, yet it is born from the most violent and chaotic event imaginable, the death of a massive star in a supernova explosion. When a star many times the mass of our sun exhausts its nuclear fuel, its core collapses under its own immense gravity. The outer layers rebound in a cataclysmic blast that can outshine its entire host galaxy, a final, furious scream of light and energy that scatters heavy elements across space. But what is left behind, At the heart of this unimaginable chaos is a remnant of perfect, compressed order. It is a neutron star. It is the collapsed core of the dead star, an object so dense that all the atoms within it have been crushed into a single city-sized nucleus of pure neutrons. A thimbleful of its substance would weigh more than all of humanity combined. It is matter at the very edge of existence, just one step away from collapsing entirely into a black hole. And as this core collapsed, it began to spin, faster and faster, like an ice skater pulling in their arms. It conserves the angular momentum of the original, vast star, but concentrates it into a tiny, spinning sphere. This rapid rotation, combined with the star's incredibly powerful magnetic field, creates two focused beams of radiation that blast out from its magnetic poles. The pulsar is not actually pulsing, it is spinning. And as it spins, these beams of energy sweep through space like the beam of a lighthouse. If the Earth happens to lie in the path of one of these beams, we see a pulse of energy every time the beam sweeps past us. The incredible regularity of the pulses is simply the perfect stability of the dead star's rotation. It is the heartbeat of a stellar corpse, a final, rhythmic memory of a life of violent fusion. It is a profound cosmic lesson that from the heart of the most complete and total destruction, a new kind of existence can be born, one of breathtaking precision and endurance. The supernova is the star's chaotic and fiery death, but the pulsar is its quiet, orderly, and eternal ghost. We now move from the realm of the orderly dead to the fury of cosmic cataclysms. We turn our attention to the most powerful and luminous events the universe has ever known, save for the Big Bang itself. These are not the slow, graceful deaths of sun-like stars, nor the comparatively gentle explosions of supernovas. These are events of such mind-shattering violence that they defy our everyday language of description. They are called gamma-ray bursts. A GRB is a flash of gamma rays, the most energetic form of light that appears suddenly from a seemingly random and empty point in the sky. For a few brief seconds, or sometimes a few minutes, this point in space becomes the brightest object in the entire observable universe in the gamma-ray spectrum. A single burst can release more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. It is a flash bulb of cosmic proportions, a blast of pure energy so intense that it would be instantly lethal to any life for thousands of light years around it. These bursts are not born in our stellar neighborhood. They are echoes from the edge of the visible universe, explosions that occurred billions of years ago in galaxies so distant they are barely visible to our most powerful telescopes. Their light has been traveling toward us since a time when the Earth itself had not yet formed, a journey across the expanding fabric of space-time. When we detect a gamma-ray burst, we are not seeing a present event. We are looking at a fossil, a postcard from a time when the cosmos was young and ferociously violent. The initial flash of gamma rays is invisible to our eyes, a ghostly and silent scream of high-energy photons. But moments later, the explosion's shockwave crashes into the surrounding interstellar gas, creating a brilliant, fading afterglow that can be seen in X-rays, in visible light, and in radio waves. Astronomers around the world will race to turn their telescopes toward the fading ember of this cosmic firework, hoping to catch a glimpse of the host galaxy and understand the nature of the cataclysm before its light fades forever into the background hum of the universe. To witness a GRB is to have a front row seat to the most extreme physics possible, a fleeting glimpse into a furnace of creation and destruction that makes all other cosmic events seem gentle by comparison. What conceivable engine could power such an ungodly blast? What celestial event could unleash the energy of a billion trillion suns in a matter of seconds? The answer lies in the death of the most massive stars and in the collision of the most exotic stellar corpses. There are two leading theories, two paths to creating a cosmic fire of this magnitude. One begins with a hypernova. This is the death of a truly colossal star, one perhaps more than 40 times the mass of our Sun. As its core collapses, it does not form an ordinary neutron star, but bypasses it entirely, collapsing directly into a black hole. As the black hole forms, it begins to feed on the surrounding star from the inside out, pulling matter into a swirling superheated accretion disk. This disk, trapped by the black hole's immense gravity and magnetic fields, then launches two ferocious, tightly focused jets of plasma and energy that blast outward from the star's poles at nearly the speed of light. When one of these jets happens to be pointed directly at the Earth, we see it as a long-duration gamma-ray burst. The other path is perhaps even more spectacular. It begins with two neutron stars, the dead, dense remnants of past supernovas, locked in a tight, decaying orbit. For millions of years, they spiral closer and closer together, shedding energy as gravitational waves, warping the very fabric of space-time around them. In the final moments, they are orbiting each other thousands of times per second, their immense tidal forces tearing each other apart. Then they collide. The resulting explosion, sometimes called a kilonova, is a cataclysm that forges the rarest and most precious materials in the universe. In this brief, violent furnace, the conditions are so extreme that vast quantities of heavy elements are created through a process of rapid neutron capture. Gold, platinum, uranium. The atoms that make up these valuable materials on Earth were not born in the hearts of ordinary stars. They were forged in the fiery wreckage of colliding neutron stars, in the heart of a short-duration gamma-ray burst. These events are not just explosions, they are cosmic anvils, the alchemical forges where the universe creates its most treasured elements and scatters them across the galaxies, seeding the next generation of stars and planets with the building blocks of complexity and perhaps of life. We are, in a very real sense, the children of this cosmic violence. The gold in a wedding ring is not just a symbol of love. It is the fossilized memory of a cataclysm that lit up the heavens billions of years ago in a galaxy far, far away. We now pull our focus back, moving from the singular violence of cosmic explosions to a stillness of an altogether different kind. Our journey takes us to a place defined not by what is there, but by what is not. We are drifting toward a region of space so vast, so desolate, so profoundly empty, that it challenges our very conception of the universe's structure. It is a desert of cosmic proportions. It is known as the Bodhi's Void. As we approach, there is nothing to see. The familiar tapestry of distant galaxies, the faint, shimmering jewels that normally dot the deep black of intergalactic space, begins to thin, and then it vanishes entirely. We have entered a realm of profound and unsettling emptiness. It is a bubble of near-perfect nothingness, a spherical chasm in the cosmic web that stretches for nearly 330 million light-years across. To cross it, even at the speed of light, would take 1/3 of a billion years. The scale is an assault on the imagination. If our own Milky Way galaxy were at its center, we would not have known of the existence of any other galaxies until the 1960s. Our night sky would have been a field of local stars, set against a backdrop of absolute, unrelenting blackness. The great cosmic conversation, the discovery of our place within a universe of 100 billion other galaxies, would have been silenced by this immense, intervening gulf of nothing. This is not just a dark patch of sky. It is a true void, an under-dense region where the great, lacy network of galactic superclusters has simply failed to form. Based on the average density of the universe, a space this large should contain thousands of galaxies, great and small. Yet astronomers have found only a few dozen, a lonely handful of galactic islands scattered across an ocean of emptiness, so vast it could swallow 1,000 of our own local galactic groups without a trace. It is as if the universe, in the process of weaving its grand cosmic tapestry, simply dropped a stitch, leaving behind a colossal and inexplicable hole. What could create such an immense and desolate space? How could a region so vast be so thoroughly evacuated of matter? The answer may lie in the very birth of the universe's structure. In the early cosmos, tiny quantum fluctuations were magnified by the rapid expansion of space, creating regions of slightly higher and slightly lower density. Over billions of years, gravity went to work. The denser regions pulled in more and more matter, growing into the great filaments and superclusters of galaxies we see today. But in doing so, they drew matter away from the less dense regions, leaving them behind as ever-expanding voids. The Bodus void is likely the result of the merger of many smaller voids, a place where the gravitational tides have conspired to pull all the available material away, leaving behind a cosmic dead zone. It is the universe's negative space, the quiet, empty canvas upon which the bright art of galactic formation is painted. To contemplate this void is to confront a different kind of cosmic awe. We are accustomed to finding wonder in the light, in the density of stars, and the complexity of galaxies. But the Bodus void teaches us that the universe is equally defined by its emptiness. It is a reminder that the stars we see are the exception, not the rule. Most of the universe is this cold, dark, and almost entirely empty. It is a place of profound, almost sacred silence. It is not a place of terror, but a place of quiet contemplation. It is the space between the notes that gives the cosmic symphony its rhythm and its meaning. In this great and silent emptiness, we are given a glimpse of the universe's underlying architecture, a structure built as much from nothing as it is from something. It is a quiet, humbling lesson in the power and the scale of the void, a silent, dark space that is as much a part of the whole as any shining star. We now turn from the emptiness that we can see, or rather not see, to an even more profound mystery, the emptiness that holds everything together. We are shifting our focus from the visible matter of the universe to the invisible scaffolding upon which it is all built. We are entering the realm of dark matter. It is everywhere. It is passing through your body as you rest, streaming through the very walls of your room, flowing through the solid core of the earth as if it were not there. Yet you cannot feel it. You cannot see it. It does not shine with its own light, nor does it reflect the light of stars. It does not interact with ordinary matter in any way we can directly detect. Except for one, it has gravity, and through this single subtle influence, it dominates the universe. It is the ghost in the cosmic machine, an invisible presence whose gravitational pull dictates the motion of stars, the shapes of galaxies, and the ultimate fate of the entire cosmos. We first suspected its existence by watching the stars. According to our understanding of gravity, stars in the outer regions of a spiral galaxy should orbit more slowly than those near the center, just as the outer planets in our solar system move more slowly than Mercury. But they do not. When we measure their speeds, we find that stars on the far edges of a galaxy are moving just as fast as those in the crowded inner regions. They are moving so fast, in fact, that the gravity of all the visible stars gas and dust in the galaxy should not be nearly enough to hold them in their orbits. The galaxies should be flying apart, their stars flung out into the intergalactic void like water from a spinning wheel, and yet they are not. They hold together in their elegant, stable spirals. The only way to explain this is to assume that there is something else there, a vast, unseen halo of mass that surrounds the entire galaxy, providing the extra gravitational glue needed to keep everything in place. This unseen mass is what we call dark matter. It is not just a little extra material, it outweighs all the visible matter in the universe by a factor of more than 5 to 1. The shining galaxies we see are but the glowing foam on the surface of a deep, invisible ocean of dark matter. So, what is it? This is one of the greatest and most humbling mysteries in all of science. We know more about what it is not than what it is. It is not made of the same stuff as us. It is not composed of protons, neutrons, and electrons, the familiar building blocks of atoms that make up stars, planets, and people. If it were, it would interact with light in ways we could detect. It is something else entirely, something new, something that lies outside our standard model of particle physics. The leading candidates are hypothetical particles, with names like WIMPs, weakly interacting massive particles, or axions. These are particles that are predicted by some of our most advanced theories, but have never been detected in any experiment. Scientists have built incredibly sensitive detectors, deep underground in abandoned mines, shielded from the constant rain of cosmic rays, hoping to catch the fleeting, ghostly signal of a single dark matter particle bumping into an atom of ordinary matter. So far, they have found only silence. The search continues. A quiet, patient vigil for a ghost. Dark matter is a profound lesson in cosmic humility. It is a reminder that what we can see, what we can touch, what we perceive as the entirety of reality, is in fact only a tiny fraction of what truly exists. We are living in a universe that is fundamentally invisible to us. We are like deep-sea fish, swimming in the crushing darkness, aware only of the faint, bioluminescent creatures that happen to glow, completely unaware of the vast, dark ocean that surrounds us, whose currents shape our very existence. Dark matter is not just a scientific puzzle, it is a philosophical one. It forces us to confront the limits of our own perception, to accept that the universe is built upon a foundation of mystery. It is the invisible hand that sculpted the galaxies, the silent partner in the cosmic dance, and the quiet, ever-present reminder that the most important things in the universe are often the things we cannot see at all. Our journey now takes us to the very edge of understanding, to a place where the familiar laws of physics seem to break down, and where the concepts of space, time, and information itself dissolve into an impenetrable paradox. We are drifting toward the ultimate abyss, the most extreme and enigmatic object in the entire universe. We are approaching a black hole. It is not a hole in the way we think of one. It is not an empty space. It is the opposite. It is an unimaginable amount of matter, the crushed remnant of a colossal star, squeezed into an infinitesimally small point of infinite density. It is a singularity. The gravity of this point is so immense, so reality-bending, that it warps the very fabric of space-time around it into a bottomless well. And at a certain distance from this singularity lies a boundary, a point of no return. It is called the event horizon. Anything that crosses this threshold, a planet, a star, a particle of light, can never escape. It is a one-way door to infinity. To an outside observer, a black hole is a sphere of perfect blackness, a hole punched in the starry canvas of the universe. It is a place where information is erased, where light goes to die. We cannot see it directly, for it emits no light of its own. We can only infer its presence by the way it affects the space around it. We see stars orbiting a point of invisible massive gravity. We see the light from distant galaxies bent and distorted as it passes by, a phenomenon known as gravitational lensing. We see matter from a nearby companion star being siphoned off, forming a swirling superheated accretion disk around the black hole's event horizon. As this matter spirals inward toward its doom, it is heated to millions of degrees, releasing a torrent of X-rays and radiation before it vanishes forever. This is the black hole's final luminous scream, the last testament of matter before it crosses the boundary and is lost to our universe. It is the ultimate predator, a silent, patient hunter that feeds on light and time, growing ever larger with every star it consumes. It is a point of absolute finality, a cosmic dead end from which there is no appeal and no return. But here, at the edge of this abyss, lies one of the most profound and unsettling puzzles in modern physics. It is called the black hole information paradox. At its heart is a simple fundamental principle of quantum mechanics, that information can never be truly destroyed. Information, in this sense, is the unique quantum state of every particle in the universe. Its position, its velocity, its spin. This information makes up the story of the particle. The laws of physics state that this story, while it can be scrambled and rearranged, can never be completely erased from the cosmic record. If you burn a book, for example, the information in its pages is not truly gone. In theory, if you could capture every single particle of smoke and ash and heat, you could reconstruct the original text. The information is merely transformed into a more chaotic and disordered state. But a black hole seems to violate this sacred rule. When matter falls across the event horizon, its information seems to vanish from our universe entirely. The black hole itself is a simple object, defined only by its mass, its spin, and its charge. It retains no memory of the complex, information-rich matter that it consumed. A black hole made from a collapsed star is indistinguishable from one made from a trillion encyclopedias. The information, it seems, is truly and utterly lost. This creates a deep and troubling conflict between the two great pillars of modern physics: Einstein's theory of general relativity, which describes the gravity of black holes, and the laws of quantum mechanics, which govern the behavior of information. For decades, this paradox has been a battleground for the greatest minds in theoretical physics. The late Stephen Hawking famously proposed that black holes are not entirely black. He showed that due to quantum effects near the event horizon, they should slowly evaporate over immense timescales, emitting a faint thermal glow known as Hawking radiation. But this only made the paradox worse. If the black hole evaporates completely, and the radiation it emits is perfectly random and thermal, then what happens to the information that fell inside? Does it simply wink out of existence, violating the fundamental tenets of quantum theory? Or is it somehow encoded in the faint outgoing radiation, scrambled in a way we cannot yet comprehend? The answer is still unknown. It is a quiet, theoretical crisis that points to a deep incompleteness in our understanding of reality. It tells us that our best theories are missing a crucial piece, a new principle that will unite the worlds of gravity and quantum information. The black hole is not just an object. It is a question. It is the place where our knowledge ends, a perfect dark sphere that holds the secrets to a deeper, more unified theory of everything, a secret that it guards with absolute silent finality. Our final destination on this journey is not a place of cosmic violence or profound theory, but a place of quiet, persistent, and beautiful strangeness. We are drifting toward a single, ordinary-looking star in the constellation Cygnus. It is a star slightly larger and hotter than our own sun, one of billions of similar stars in our galaxy. But there is something deeply unusual about it. It does not shine with a steady, constant light. It flickers, it dims, and it does so in a way that is utterly bizarre and unpredictable. This is Tabby's star. For years, astronomers have monitored the brightness of stars, looking for the telltale, regular dips in light that signal an orbiting planet passing in front. But the dimming of Tabby's star follows no pattern. Sometimes, its light will dip by only a tiny fraction. At other times, it has been observed to dim by more than 20%, a colossal drop in brightness that would require an object of immense size to block its light. And these dimming events are not periodic. They happen at random, lasting for days or weeks at a time, before the star returns to its normal brightness. What could cause such erratic and profound changes in a star's light? The first and most obvious answer: a cloud of dust or a swarm of comets orbiting the star seems insufficient to explain the sheer scale and irregularity of the dimming events. A cloud of dust, dense enough to block a fifth of the star's light, should be heated by the star and glow brightly in infrared. Yet we see no such excess heat. A swarm of comets seems unlikely to be able to coordinate in such a way as to produce these deep, prolonged dips. The strangeness of the signal led some to a much more sensational and extraordinary hypothesis. Could it be that we were witnessing the construction of an alien megastructure, a Dyson swarm perhaps, a vast collection of solar panels being built around the star by an advanced civilization to capture its energy? It was a tantalizing, almost romantic idea, the thought that we might be inadvertently seeing the industrial workings of a society far beyond our own. It captured the public imagination, a brief, shining moment of hope and wonder that perhaps, just perhaps, we were not alone. In recent years, the alien megastructure hypothesis has faded as more mundane, though still not entirely conclusive, explanations have come to the forefront. The leading theory now suggests that the dimming is caused by a vast and unusually structured cloud of cosmic dust. Not a smooth, uniform cloud, but a clumpy, uneven one that orbits the star in a long, eccentric path. This could explain the deep, irregular dips, as different parts of the fractured cloud pass in front of the star. But even this explanation has its problems, and the mystery is not yet fully solved. Tabby's star remains a beautiful and persistent anomaly. It is a quiet testament to the fact that the universe is still capable of surprising us. It is a reminder that there are still phenomena that do not fit neatly into our models, that challenge us to be more creative, more open-minded, and perhaps that is its true purpose. It is a cosmic riddle, a star that winks at us from across the light years, inviting us to speculate, to imagine, to wonder. It keeps a small piece of the great cosmic mystery alive in our hearts, a quiet, flickering light that reminds us that there is still so much we do not know, and that the universe is all the more beautiful for the secrets it still keeps. And now our journey through the strange and unsettling corners of the cosmos comes to a gentle close. We have stood before the pillars of creation and watched a dying star gaze back at us with a serene and colorful eye. We have puzzled over a galaxy built like a perfect, lonely ring, and listened to the momentary shouts and the steady heartbeats that echo from the deep. We have drifted through the great silent emptiness of the void, felt the gravitational embrace of an invisible substance, and stood at the edge of the abyss where information itself seems to die. And we have ended our journey with a single flickering star, a quiet, unsolved riddle that keeps our sense of wonder alive. These strange phenomena are not flaws in the cosmic design. They are its most beautiful and intricate features. They are the universe's poetry, written in a language of light, gravity, and time. They remind us that our understanding is a small, flickering candle in a vast and beautiful darkness, and there is a profound peace to be found in that knowledge. There is a comfort in accepting the mystery. You do not need to solve these riddles to be a part of them. The same atoms forged in the heart of a gamma-ray burst are within you now. The same invisible dark matter that holds the galaxies together flows silently through you. You are a part of this grand, strange, and beautiful unfolding. So now, let these cosmic thoughts begin to fade. Let them dissolve like starlight in the morning mist. Feel the gentle, steady pull of gravity, not as a force that holds you down, but as the quiet embrace of the earth. Your own small blue island in this vast cosmic sea. You are safe here. You are at rest. The universe will continue its slow, silent dance. The pulsars will keep their time. The strange stars will flicker. But your only task now is to let go, to drift into your own inner space, a universe of quiet, peaceful darkness. There is nothing left to do, nothing left to solve. There is only rest. Sleep well and dream softly. Good night.